Hello and welcome to G Fun Facts Online, the show that brings you the most amazing science from our universe. Today, we're talking about the ultimate delivery service, one that spans millions of kilometers and brings back packages that are literally out of this world. We're talking about robotic interplanetary couriers and their daring missions to collect pieces of other worlds and bring them home. It's not just about observation. It's about touching, holding, and studying the very stuff our solar system is made of. So how do you mail a package from an asteroid? Let's find out. The biggest challenge isn't just getting there, it's the round trip. Imagine planning a road trip where you have to use the gravity of other planets as a slingshot just to get up to speed. That's what these spacecraft do. Once they arrive at their destination, say an asteroid, they have to perform incredibly complex maneuvers to orbit and then gently touch the surface to grab their precious cargo. But the return journey is even more intense. The spacecraft has to fire its engines with perfect timing to escape the asteroid's gravity and fly all the way back to Earth. The grand finale is a dramatic fiery plunge through our atmosphere. A small capsule, protected by a massive heat shield, separates and hurtles towards the ground at hypersonic speeds. Then, a series of parachutes deploy to ensure it lands softly, ready for pickup. Several incredible missions have paved the way. Take NASA's Genesis mission, which aimed to collect particles from the solar wind. After spending 2 years soaking up the sun's particles, its return in 2004 was a bit of a disaster. The parachute failed, and the capsule crash-landed in the Utah desert. But scientists, in a heroic effort, managed to recover many samples, giving us groundbreaking insights into the composition of our sun. Then there was Stardust, the first mission to bring back solid samples from beyond the moon. In 2004, it flew through the dusty cloud of Comet Wild 2 using a bizarre material called aerogel, a sort of solid smoke, to catch the tiny particles. The samples showed that this comet, formed in the freezing outer solar system, contained materials forged near the hot sun, completely changing our ideas about how the early solar system was mixed together. And we can't forget Japan's Hayabusa and Hayabusa 2 missions. Hayabusa 2 visited the asteroid Ryugu and performed 2 daring touch-and-go maneuvers, even firing a bullet into the surface to create a crater and collect pristine material from underneath. It returned over 5 grams of rock and dust in 2020, so why go to all this trouble? Because studying these samples in our labs on Earth is a game changer. We can use equipment that's far too big and power-hungry to ever put on a spacecraft. The discoveries have been mind-blowing. The samples from Ryugu are some of the most primitive materials we've ever seen, a direct window into the solar system 4.5 billion years ago. Scientists found Ryugu is rich in water and organic materials, including over 10 types of amino acids, the building blocks of life. This is powerful evidence for the theory that asteroids delivered the essential ingredients for life to a young Earth. The success of these missions has inspired even bolder plans. NASA's OSIRIS-REx just returned a massive sample from the asteroid Bennu in 2023. And scientists are ecstatic to find it's also full of water and carbon. But the holy grail is the Mars Sample Return Mission. This is a multi-stage, multi-agency campaign to bring back the first rocks from Mars. NASA's Perseverance rover is already on Mars, collecting and storing core samples. The next step is to send a lander with a small rocket, the Mars Ascent Vehicle. This rocket will perform the first ever launch from the surface of another planet, putting the samples into Mars orbit. Finally, a European orbiter will catch this container and fly it back to Earth, with an expected arrival in the early 2030s. And the ambition doesn't stop there. Japan is planning to get a sample from Mars moon Phobos, and China is planning its own Mars sample return. But it's not easy. A huge concern is contamination. We have to make sure we don't send Earth microbes to other worlds, and more importantly, that we don't bring anything dangerous back to Earth's biosphere. This requires incredibly strict safety protocols. These interplanetary couriers aren't just collecting rocks. They are gathering the clues to our own cosmic history, helping us answer the biggest questions. Where did we come from? Are we alone? Each tiny grain returned from space is a testament to human curiosity and a step toward understanding our place in the universe. Thanks for tuning in to G Fun Facts Online. Join us next time for another deep dive into the wonders of science.